Hi, this is Kathy Keener with Piping Solutions and TRIFLEX, and I'm going to try to quickly explain the max displacement stress range stresses coming from B31.3 and how that affects our piping code report and our case definition. Okay, so when you open up a piping code report and you have max displacement stress range stresses checked, then you're going to see these extra columns. This is actually a B31.1 piping code report. The maximum displacement range stresses are coming from B31.3. And that's you shall look at the every operating case should be considered when you're trying to get to the maximum displacement stress range stresses. Okay, so that's a you shall in B31.3, but not the other ANSI codes. TRIFLEX makes it available in all the ANSI based codes. Okay, so you'll see your sustained stresses, pressure and weight, your expansion stresses, thermal pressure and weight, and then you'll see displacement range cases, and you can see the pairings. This was case 4 to case 10, case 6 to case 10, different various cases that got us that high expansion stress range. Now you're going to see those numbers, those same numbers on each of the cases. Okay. Also, TRIFLEX is looking for the maximum sustained case as well, and noting that as participating. All right. So under setup and modeling defaults, displacement stress range as a max difference amongst cases is checked. That is a factory default. You can uncheck it. Typically, I leave it on because I want to see my max displacement for each case. But when I'm reporting, I'll uncheck it, rerun the calcs, report on each of the cases separately, then go back, recheck it, run it, and report on the maximum displacement stress range stresses as well. So with this checked, a couple of things happen. You'll see these two columns here appear in your piping code report. But let's go see setup and case definition and see what's happening here. It says all operating cases without occasional loads will participate in a piping code calculation. A cold sustained case is required for accurate analysis. So you can see here we have our cold sustained. Our first case is our standard operating case. That means where the system is generally going to be. What pressure, what temperature it's generally going to be. Your installed case is what has your cold sustained case, and I'll tell you why we call it that in a minute. And then we have your design cold and design hot and some seismic cases. The reason that we're looking at the displacement stress range stresses like that and putting in your designed cold and your designed hot cases is because we want to look at some of the temperatures that may actually happen if you have above ground pipe, right? So for instance, in Texas, you might have near Houston, Texas, you might have an installed temperature of say 70F, right? You've got maybe an operating temperature of 100. Then you've got a design hot, or what I like to call a design hot, 125F. And then maybe you've got a design cold you want to look at, say only about 20F, okay? So the idea behind this is that the piping code, especially when you're considering the non-conservative allowables for displacement stress range stresses, will allow pipe to go from its elastic range into its plastic ranges. Once it gets into the plastic ranges, a percentage of the deformation can be permanent. So instead of doing a case that's going from, say, 70 to 20, right? And assuming that this hot design case is going to just settle right back at 70, right? And then you're going to just go from 70 to 20. We're not considering that. We're considering that this may be landing in the plastic range, and it may be somewhere here, you know. Usually you might do like a 150 to consider the pipe sitting out there in the sun. So maybe it's going from 125 or 110 or 100 to 20. Okay, so maybe it's sitting in somewhere in here in this position rather than completely relaxing and going back to 70. So and so that's why we're looking at 70, or rather 20 to 150 if you have a 150 design case instead of a 125 design case. So your maximum displacement is going to be from here to here. Now when it comes to looking at cold sustained or hot sustained, the code said you shall look at both, and then basically that's just in the quote cold sustain, you're going to be looking at a sustained condition where your pipe is, say, resting here, and each of these supports are getting loads, but in the operating, it's possible that maybe one of them is lifting off, and the other two are taking a little bit more load, right? Because this one is not taking as much load. So that would be what we call a hot sustain, considering the operating position as kind of a long-term scenario, right? So we look at both of those. And so that's why you see the word cold sustain. Okay, so TRIFLEX typically, historically, had done the hot sustain and the cold sustain, looked at both of those, and if it were lifting off, it would go for the hot sustain condition. And the code said, you need to do the maximum of either or. Okay, so that's what TRIFLEX is doing, and that's why you have maximum displacement stress range stresses from B31.3, and TRIFLEX makes it available in all the ANSI-based codes. And like I said, you're getting that from setup, modeling defaults, and displacement stress range is max difference amongst cases. And if you have this checked, it is required that you have that cold sustain case in your case definition cases. Okay?